In today's lesson, we'll be looking at how to graph when you're given an equation of a line, right? So our equation of a line can come in three different formats. We have our slope intercept, our point slope, or our general form. In order to graph, we need to have 2 points. And then you simply just draw a line through those 2 points, right? So how do we get those 2 points is the key question. In the first question, A here, we're given our information in our slope-intercept form. We've told the intercept, the y-intercept is 4. So we know that one of our points is at y value of 4, x value of 0. And now we need to determine another point. Right? And we determine the second point from our slope. Our slope is 2. In other words, it is 2 over 1. Our slope is rise over run. This means the next point is going to have a rise of 2 and a run of 1. So we're going to go up 1, 2 over 1. And you can continue this trend. We can go up 2 over 1. Or we can actually go the other way. We go down 2 to the left 1. Right? All you need is 2 points. Once you've got your 2 points, you simply draw a line through those 2 points. Right? And you can put little arrowheads on these, because this line actually continues on forever. Now, in the middle situation here on B, we're given a point slope form, right? We need to have 2 points to start off with. Well, one of the points is listed with the x and y values here, right? Remember, this point slope form tells us that this line goes to the point -1 and +2, right? So recall that it's y minus y1 is equal to m times x minus x1 in brackets. The negative sign switches the sign of the point, right? So our first point is at x value of -1, y value of 2. Now we use our slope, which is 2, to determine another point on the line. So our slope, just like before, is 2. So a rise of 2 and a run of 1. So we go up 2 over 1. That would be our line. Now grab your ruler. And draw your line. Okay. In the general form, things are just a little bit trickier because we are not given a point right from the equation of the line. Right? However, we can figure out 2 points by solving the equation. So the 2 points I say you solve for are the x and the y intercepts, because they're easier to solve for. Because to determine the x-intercept, we set a y value equal to 0. And to determine the y-intercept, we set the x value equal to 0. And we plug those into the equation. And we solve for the value of x. And we solve for the value of y. So for this equation, we know the x-intercept is at -2, 0. And we know the y-intercept is at 0, 4. Right? You could solve for any point. You could say set y equal to 4 or so y equal to 5 and find out what the x value is, right? Just whatever you feel like doing. I usually find the x and y intercept easier to solve for because they involve zeros. Okay, so you simply plot your 2 points. Our y-intercept was at 4. Our x-intercept was at -2. And then we simply draw a line through our points. and hoping that you're noticing that this is the same line, just represented in different formats. So we've drawn the exact same line, even though the equation looked different. So it's something to be aware of, right? So under your notes here, if you like, you can write out the steps if you have a hard time remembering what we did here. Or you can just simply continue on to the next question, right? In the next question, you're asked to match the equations given here on the left-hand side to the 4 graphs shown. Graph A, graph B, graph C, graph D. Okay. What we need to do is determine what are the y-intercepts, or at least one strategy I would suggest to matching these things up is determine the slopes, determine the y-intercepts of the equations and of the graphs, then match them up, right? So, but there's other strategies you can take. So I'm going to ask you to pause the video, either try the strategy I suggested or try a different strategy to match the equations up to the graphs. So hopefully you came up with the equation 1 matches up with the D graph, equation 2 matches up with A graph, equation 3 matches up with C, equation 4 matches up with B. If you didn't get these, how was it done? Well, I'll zoom over to each one. Each of the graphs, I found the slope and the y-intercept. So I had a characteristic there that can match up with the equation of the line. So with A, we end up with our slope of -2 and our y-intercept of 3. With graph B, we had our same y-intercept of 3 and our slope this time was 1/2. With C, we found our y-intercept to be -3 and our slope to be -1/2. And with D, we found our slope to be 3. Our y-intercept to be 3 and our slope to be 2/1, right? So those are the characteristics of the lines from the graphs. The equations, we need to find the same characteristics so we can match them up, right? With equation 1, our slope is 2, our y-intercept is 3. Equation 2 is a little bit easier, so already written in slope-intercept form. Our slope is -2 and our y-intercept is 3. And in equation 3, I used a point just because it was in slope point form. So our point was -4 and 1. So I could look that off the graph, and a slope of -1/2. And with equation 4, it was written in general form, so I had it converted to a slope y-intercept form, and the slope was 1/2, and the y-intercept was 3. Okay, we're going to skip question 3 and go to the last question of the day, which is question 4. Okay. In this question, you're asked to graph the data that's provided here, then come up with the equation of the line. So pause the video and try this question. So after graphing your point, you can draw a line through it and extend it through, and you can see that the y-intercept is -2. That's where the line crosses the y-axis, and the slope, the rise over 1, is equal to 1/2. This tells us the equation of the line must be 1/2 x minus 2. Okay. So that's the last example for the day. Give the homework questions a try, and if you have any problems, just get in contact with me.